In this video, what we're going to be doing is looking at double replacement reactions that produce water. So the practice problem that I want to do together is sulfuric acid reacting with aqueous potassium hydroxide. So one of the ways that we're able to tell that a double replacement reaction is going to happen is when a precipitate forms. The second is when water forms, and that's what this example is going to look at. So double replacement reactions that form water. Previously, we looked at double replacement reactions that formed a precipitate. The first one we're going to look at is H2SO4. That would be an aqueous solution of H2SO4 reacting with an aqueous solution of potassium hydroxide. H is a 1 plus and SO4 is a 2 minus. K is a 1 plus and OH is a polyatomic ion that's a 1 minus charge as a group. So when we look at this example, what we're going to do is allow the H plus to go with the OH minus. When the H plus goes with the OH minus, it forms H2O. So we get this product as being H2O. H plus with, technically it looks like this, HOH. The H is a 1 plus, the OH is a 1 minus, and they come together. Now we know we typically don't write as HOH, we write as H2O. Plus, K is a 1 plus, SO4 is a 2 minus, so we end up with 2 Ks and 1 SO4. And then this would be an aqueous solution. The way that we would know it's an aqueous solution, the way that we would know that it's an aqueous solution is we would look at our solubility chart, and K with an SO4 is soluble, so that means it dissolves. But because H2O in the liquid phase is formed, this reaction would take place. One of the ways to know if a double replacement reaction is going to take place is if we get a solid precipitate being formed. Another way is if water is being formed. So I'd like to do one more example where water is formed. And in this one, what we will do is we will do question number 39, HCl and calcium hydroxide. Sorry about that. Number 39, HCl, hydrochloric acid, and calcium hydroxide. So what we're going to do is we're going to take HCl, which comes from the 1 plus H in the 1A column and a 1 minus Cl, plus calcium hydroxide. Well, calcium is a 2 plus because it's in column 2A. Hydroxide is a 1 minus, so we know there's going to be 2 OHs for every single one Ca. So what happens is this 1 plus with the 1 minus once again becomes HOH, essentially H2O in the liquid phase. We're forming water, plus, and now this time calcium is going to be bonded with Cl, the positive with the negative, but the positive is always written first. So there's going to be 2 Cl's for every Ca. So we write it CaCl2. When we look up calcium chloride, calcium and chloride is soluble, so we write it as an aqueous solution. But we know that this double replacement reaction is going to take place because it's forming water. This is our second way we know if a double replacement reaction is going to take place. The first is there a precipitate formed? The second is water being formed? Now on this second one, we need to be careful because I think we need to balance the equation. And to be honest, I actually forgot to balance the first one. We have two H's there, so we need to put a 2 right here. And we also now have two OH groups. In balancing these, I would keep the OHs together as a group. So then I'd put a 2 right there. So now I have 2 Ks and 2 Ks. And now everything's balanced. 1, 2, 2, 1. If I go to the second one, I know that I've got two OH groups here and only one OH group there, so I put a 2. But now I have two H's and only one H, so I put a 2. Now I have two Cl's and two Cl's and one Ca and one Ca. So that balances 2, 1, 2, 1. This is the second way that double replacement reactions can take place by forming water.